Okay guys, just a little update on the new project build. So at this stage I've got some exciting news. I've got a new smart solar charge controller, some Anderson plugs for the box and a USB charger. Then obviously, as you've seen in the previous video, I've got the Mueller Energy. I found out it's Mueller, not Muller Energy. BMS. So basically it's got all these connections in here. I was just checking them all over earlier and just wanted to make sure that I had everything right in the right position. You got your balancer here as well, and this is going to work out beautifully for my swollen cells. I think this may actually save the swollen cells, but yeah, I've also got something else in store for those swollen cells. Not too sure if I'll film it, but I'm going to try and crush them back into shape after discharging them quite a bit. Now, I don't know if I'm going to film it or not, but we'll see. I've just tried the only thing I thought I'd be able to do, and that is put a jack under the cell with 2 pieces of timber, and as you can see, use the shank to help it push down. But this is obviously the heaviest thing I've got as my car, and I've jacked it up quite a bit. I don't know if you can see that. The aerial is actually on the inside, gone up quite a bit. So I don't know how much further I should jack this up. It has squashed the cell a little bit, so maybe I just do little bits at a time for all the cells. We'll just see. Well, I don't know about you guys, but I think that's pretty damn good. That's actually made a massive difference to the size of that cell. I wonder what it will do to the actual capacity. I think from the old video that I did on these cells, I got 252 amp hours. I might have to do a little capacity test on them before I put them in a battery pack together. Well, I'll put them in a battery pack together and then do a capacity test, but it'll be interesting to see the results for this one. As you can see, it's gradually but surely it's lifted the back end of the Patrol up. It's the heaviest thing I've got. It's the heaviest thing I own. Now, I've seen other videos online on how to compress the cells properly, but this is pretty much all I've got in the garage at the moment. I just wanted to see if they would even budge from the size they were originally, but that's actually pretty impressive seeing that. I'm actually quite gobsmacked because that was the widest cell out of all of them, and as you can see, it's almost back to normal except for the bulges, of course, on the sides. But yeah, that's actually pretty good. Now, I'm not too sure if you can see that on camera, but there's one that I haven't crushed right here. And that's the one that I just did on the Patrol, under the Patrol. Quite a big difference. So I don't know if these camera angles are going to do any justice. Shrunk it down to about 8.5 centimeters, the cell. I'll measure the next one again and actually get the correct measurement, because I had the square around the wrong way and I was reading it the wrong way. But yeah, it's making quite the difference. So I don't know how well that is showing up on camera, but you can see the difference in the two that I've crushed to this big bad boy here. I'll measure it. So I don't know how well that's showing up on camera, but that's about 10.5 centimeters. Yeah, about 10.5 centimeters, this one. Let's see how it goes when it gets crushed. Now, of course, I don't recommend doing this at home. I'm doing this just to see what actually will happen. Hopefully that showed up on camera, but it's such a massive difference. Now I'll let it sit here for a little bit. I don't know if that makes a difference at all, but it definitely shrinks those cells. Well, there's the most accurate representation of how much it's crushing that I can see. It's just on, I'd say 9 centimeters, maybe 9.2 centimeters wide now. That is absolutely incredible. Well, I'm going to knock over the fourth one now. But I can tell you right now, that's the closest those cells have ever sat together in a long time. This one's actually about 10.7 centimeters wide. So, we'll see how this one goes. Well, there we have it, down to about 9 centimeters, just about. It's 1.7 centimeters. I've crushed them down. That's quite a lot, and that's about an average on all of them. That's very impressive. I did not expect to get that much of a result, and luckily enough there's no electrolyte leaking out of the top of them or anywhere around them from what I can see. So we're just gonna check what their voltages are now, because they've been sitting for a couple of months. I have not touched them at all since doing all those tests. So we'll just see how badly out of whack they are, eh? Alright, see if I can get this camera on the right angle. Alright, cell 1, this is the big boy. 3.318. Cell 2, 3.318. What the hell? 3.319. So what the hell? 3.319. What the? All the cells are level. It's been months. They've been sitting for months. I thought for sure they would have, I don't know, I suppose, look. That's insane. Maybe there is some hope for these cells after all. Well, now we've got to make up some makeshift bus bars because the cells are too wide to actually use normal bus bars. So I'm going to have to use some custom ones when I need to do high discharge currents, but these will do for now. Okay, and now thanks to the magic of editing, I'm going to put all of these on the cells, getting ready for parallel top balancing basically. There we have it, all the bus bars made up. So I also gave them a little loop so that I could check if there's any current flow going in between them. So 0.3 milliamps, 0.3, 0.3, 0.2. Let's see, 0.5, 0.5. I dare say that is practically nothing. Now I can't remember when I put these away if I just balanced them or not, or I honestly cannot remember. I think I just left them as they were a couple of months back. I was gonna discharge them before I crushed them, but I just thought, oh, I'll see how one goes anyway. And surprisingly, they're still here and still going fine by the looks of things. So I might charge them up with the power supply. Take a couple of days from what their voltage says. So yeah, I'll come back when they're completely charged up, and we'll go from there. Well, there we go. It's on charge. Power supply unit is set with a multimeter, charging at 4.93 amps. Well, there we go. We're nearly finished charging. Won't be long, I'd say. Alright, the cells topped up yesterday and they're sitting on 3.4, I think it was 3.45 now, resting. Just have a look, see. 3.44 on the multimeter now. So I'm just going to hook them all up now in series, hook them up to a BMS, do a quick discharge test, bearing in mind that they were 252 amps. They had 252 amp hours in them last time. Hopefully we'll see some sort of gain or loss because they've been sitting for months now. Very interested to see what actually goes on here because, yeah, obviously there's not a lot that you see online about bloated cells and what can happen to them, especially LiFePO batteries. Very interested to see what the test results are. How's that? No word of a lie, I've never stuck those cells in there, and if I didn't crush them, there is no way in heck they would have fit. That's such a snug fit. They don't move at all. Oh, that's crazy. If I didn't crush them, there's no way they would have fit whatsoever. Having a look at everything, all wired in now, got the active balancer hooked up. And that's one of the main reasons I wanted this particular BMS, because it came with an active balancer, and obviously having swollen cells that are half stuffed, we want to take care of the cells and balance them as much as possible. Now, the funny thing about this screen says it's at 100%, page 2. 249 amp hours. I don't know if you can see that. Now, I don't know how, but you know, last time we tested that battery, 252 amp hours. So I'm quite astounded that this screen already knows that. And we've got, and there you go. We've got all of our cell voltages. And they're not too bad actually. They could have been a lot worse, especially for the state of those cells. I'm quite gobsmacked at that. So we're going to be testing out the Mueller Energy BMS. Definitely looks like a great unit. Got your temperature sensors, everything in here. Oh great, it's going to start raining. I've got to close that garage. Okay, let's see what goes on. Got the shunt reset. And plug in our light bar and two H4 bulbs as a load. May add some more later, we'll see. It's pretty accurate, that shunt. So it even gives you a time till empty. 8 minutes 29, 8 hours 32 minutes. I really like this screen that comes with the BMS. It's fantastic. Temperature's coming up. And temperature sensors are really good. You can also turn discharge on and off. As you can see, the light turns on and off. It's actually really handy. So after a little bit of hunting on the internet, I found the proper app that works with this, that's unlocked. So basically I can go through and check all the different settings for the app. The app that you gotta use the barcode on the Bluetooth module for, it doesn't let you get into everything and check everything the way you want to. You can monitor it, but every time that you want to connect the Bluetooth, unfortunately you have to use the barcode to scan. So that's a little bit unfortunate, but with this app it connects straight away. So okay guys, I started running out of time, so I need to speed this test up. We're at 186 amp hours and I've just wired up, get this out of the way, as you can see, just jigged up 50 amp Anderson to 120 amp Anderson into the King's inverter that I got for a score, $209 on eBay the other day. So standby current's actually not too bad, it's only 1.5 amps by the looks of that. Don't know if the camera's picking that up. Now I know I'm only running through a 50 amp shunt. Well, the shunt can do 500 amp, but I've just wired in 50 amp cable through there. So I'm not going to push it too hard. We'll stick something on here and speed up this test a bit, hey? Okay, as you can see, we've got a bit going on here. So we've got that battery charger charging one of my old lithium batteries that I had in the camper. That may end up in that system yet, not too sure. Now I've got this other power board hooked up. That extension lead runs up to power all 4 of these lights all the way around. And then after powering all 4 of those lights, I've got another line running over here to charge up one of Carter's batteries for his Mojave remote control car. Now I've been trying to find everything that's the least noisiest thing in the house so that I don't annoy everyone, but I think 35 amps is pretty good. Might leave it at that for now, because this cable isn't hot at all, it's just warm, so I don't want to push my luck too much. But for some reason these lights, I could be wrong here, but these lights were running on about 15 amps from memory just by themselves through the Renogy inverter, 3000 watt inverter on the camper. But for some reason it was only about 11 amps before when I was checking it. Now it could just be because it was running through a really long extension lead, put a little bit more load on the batteries in the camper. Could be wrong, but yeah, we'll see how this goes now. We're at 190 amp hours. Hopefully it speeds up the process. And the best part about this is I didn't get the big crack when I plugged in the inverter because you can turn the discharge on and off and shut everything on and off safely. So supposedly we only got 34 amp hours left. 191 plus 34 amp hours. You do the math. We'll see. We'll soon see what it actually pulls. So as you can see, I've got this other laptop running as well. So I've got two laptops on charge. That other battery charger for that lithium battery. Then I've got the remote control battery as well. That's getting charged at 5 amps now. I've turned it up. Running at 41 or 42 amps, 43 amps average. It's not too bad. Sorry, there's a reflection there. Bring it up for you. Try and get the right angle so you can see that. So it says 0 to 15 minutes empty till empty. How are these cells doing? Still plenty to go in them. There's nearly no cell deviation. There's next to nothing. It's so good. So impressed with these cells. Wonder if you can... Well, I suppose I'm just going to use them for this battery pack until they die. Why waste them, hey? $233 amp hours so far. Got two laptops running videos. We've got a power supply running a mini heater. We've got that power supply charging up the other battery. Just we'll finish that, charging that battery. Then that lithium battery topped up, so I had to hook up a little 10 amp heater. So yeah, should hopefully be finished soon. It's 10:30 at night now. I was hoping to get this done a bit earlier, but the battery just keeps prevailing. These cells just keep proving me wrong. I'm hoping to get some sort of reaction out of them, but I get nothing out of them. Nothing bothers them. And we're doing 39 amps. Yeah, 39 amps at the moment. Now I'm also going to hook up this charge cord to the camera and charge it up as well. Alright, well the battery for the camera's fully charged up, but now I've got low voltage on the inverter. You can hear it beeping. So I'll disconnect the inverter and then finish off using the light bar, I think. Okay, I don't want to get too excited, but we exceeded the amp hours drawn, guys. We're at 262 now, and we still have 11.5 volts. That's absolutely fantastic. So it looks like crushing the cells does actually lift the electrolyte up in the cell, and actually does make a difference. It almost makes me want to crush them a bit more when they're fully discharged. That's awesome. Alright, so the cell differentiation is quite high now. It's 0.239 millivolts, which is quite a bit, and we're down at 11.1 volts total. But we've got 266 amp hours. Been running for 9 hours and 45 minutes. It's nearly 12 at night. We're just dropping down 10.8 volts. I reckon we're about to go flat. We've got one cell on 2.6, which means the BMS should cut out soon. There we have it. We just cracked 2.4. The voltages are recovering, but we've got 267 amp hours. So considering that they were 280 amp hours, and I bloated the heck out of them. Then absolutely smashed them with the inverter in another video. I'll put a bit of a video in for you to watch. Alright, we're going to try and see if we can overload the BMS. 340, 350 amps, 360, should cut off soon, should be 11.4 volts. And that's the inverter is what's cutting out. That's disappointing. The BMS didn't cut out. But amazingly, I just turned the heater down a little bit. Amazingly still doing it out of those cells. Now, that's just incredible. After crushing them, I've got another 15 amp hours. I don't want to push it, but I'm wondering if I should crush them a little bit more. But yeah, maybe I just leave them alone. I'm so happy with that. That's just absolutely phenomenal. So happy. And that's actually another good thing. Just bring this up here. This stays on so we can see what's going on. You can see we've got a fair bit of deviation now. We've got 0.294 milliamps of deviation between the cells. I'll come back in the morning after fully charging the batteries. That's going to take ages, but yeah, we'll see how much I can push back into it. I'll reset the shunt actually and use the shunt and charge it back up that way. Let's see how we go. So as you can see, guys, I've just got a 10 amp charger on the battery. It's been running since last night, 12 o'clock. It's now 5 o'clock tomorrow afternoon, so it's been on for a long time. I found out that my other 20 amp charger finally kicked the bucket. So as you can see, it hasn't started balancing yet, but all the cells are within 0.004 millivolts of each other. So they're extremely level. I'm quite shocked at this test, to be honest. I did not expect the test to go as well as it has. Let me know what you think it's going to charge up to, guys, in the comments. And thanks for watching. Yeah.